Hi, this video is designed for a mechanic that's already familiar with the general operation of a vending machine and familiar with its components. This video is going to be go over the various techniques or the method of removing a sealed refrigeration system from a stacked soda machine and then replacing it. Today I'm working on a Dixie Narco machine. There's various models of Dixie Narco machines, but the procedures are very much the same, as well as a Royal, Vendo, or even older soda machines. Basically, just kind of go over some general tips on how to do this, and then based on the exact model that you're working on, you'll have to deviate a little bit. It's going to be very easy to do. For this Dixie Narco, I'm going to need a 9/16, and I have a wrench. The socket set will work sometimes. Phillips screwdriver is always required, and then in some cases a nut driver might be needed for a Dixie Narco machine. So I would basically have a complete toolbox with you, but very few tools are actually needed, and it's a very simple procedure. So you could watch the movie a couple times. If you've never done it, then you should be fine. First and foremost, before you start this, is unplug the vending machine, and then just have a good wide open area so no one's bothering you or kicking your tools around, because it really only takes 5 minutes. First thing that we're going to do is remove this delivery port right here. In this case, it's held in with two Phillips screws. Other machines, some of them have a nut and a Phillips screw, but this one is just two Phillips screws. So I'm just going to go ahead and remove this delivery port. So after I undo these screws, this will kind of lift up and outwards. Kind of place that far out of the way. That gives me immediate access in here. Next step, I'm going to go ahead and remove this guard panel from the lower area. And this is also done with the Phillips screws. If you have a electric drill or driver, that would certainly speed the process. Some older Dixie Narco machines, they do not even have this extra plate in here. So, like I said, different models will require slightly different procedures. This one's a little bit more time consuming than the older versions. That's reasonably common. A lot of these screws, if they get old and rusty, they can be a little challenging to get out. If that's hard, you don't have the wrist strength, it could be a good idea to put some WD-40 on the screws, or at least have it available. I'm going to turn to get my strength. That one's finally come out. There's two more screws are hidden over here. The screw's a little more difficult just because these wires are in the pathway of my screwdriver. I'm going to lift this metal plate up and out, and that gives me access to this lower unit. So in the next section of our video, I'm going to go ahead and talk about removing the evaporator. Alright, in order to remove our upper unit, this piece right here, I'm going to remove this. On some other machines you'll see screws, but basically, generally there's going to be some type of a metal band and then some insulation. On this particular one, there's two clips on the bottom. So I'm going to pull these downwards, and then that releases it. Then I'll lift this up and over this area right here. A little bit of insulation here that I'm going to peel back, because when I replace this, I'm going to want to reuse that. While I'm working here, I'm going to go ahead and just out of ease, I'm going to disconnect this motor right here. Sometimes having these wires out of the way makes it easier. So get that out of the way. Basically this solid copper tube is sealed. You have to be very careful not to crimp or break this, because then you would be venting the refrigerant, which is a big no-no. This particular model of soda machine has 2 screws right here holding the shield, and I'm going to go ahead and remove those first with my Phillips screwdriver. It's kind of nice to have a medium-sized screwdriver. I think I got lucky on this screw. It's coming out. Sometimes these are stripped, and often due to the moisture in here, they can be very difficult to get out. So I've kind of over the years had my fights with these screws, but this one came out. So and not all machines have this. Now I'm going to move over to the left side and undo a similar screw. So I've got this other sheet metal screw out, so I'm going to lift this. Now this exposes the motor. In the event that you had a bad motor, these same procedures would be followed, and this is kind of teaching you how to get to this back motor. There's going to be either 3 or 4. Generally there's 3 screws holding in this upper unit. On each side they have these little bend over tabs. I guess after they put the screws in, they just bent this down. It just kind of holds it in place a little better. The upper right hand screw, I'm going to use kind of a smaller shaft screwdriver. Generally this is nice because I can use this for all screws. If you're not able to do this, or you need to, you could just get a larger screwdriver, and that would make this job a bit easier. But I'm going to try my luck with my one size fits all for the day. Kind of get back here, you need to be a little careful with your hands because this metal can be sharp. Things do move around a bit, and there we go, that one screw's out. While I was undoing the screw, if I pull the unit towards myself, that makes it a little easier. This side might be a little harder for you to see, but there's an upper and a lower screw, which I'm going to go ahead and undo these 2 screws. Okay, I got very lucky today. Sometimes you may need to use WD-40, or just a longer screwdriver sometimes helps. Basically, this unit right now is loose. My thermostat is right here, and I guess the probe is back. I'm going to kind of make sure that this cord right here is not getting my way. I don't want to snag on anything. I just want to be able to pull this unit out free and clear. So my next step is to go ahead and remove the lower section, which I'll show in the next section. Okay, it's a 9/16 is the most common size that's going to be holding these bolts in. I kind of like this wrench right here because this side is kind of has a ratcheting effect. You could use a actual ratchet wrench, but this is kind of small enough, and like I said, there's different configurations. This one right here I consider a little bit more difficult than the others, just because the nuts are not quite as accessible. I'm going to go ahead and do the one on the left hand side is very easy, so I'm going to begin just loosening this. Once you sometimes if this is straight and flat and level and hasn't been banged around, you can remove the bolts once you kind of loosen them. This one right here, I'll lift these fins up a bit, and I can kind of start ratcheting with my wrench. And I don't get that much of a throw right here, just because it's very limited. Even with a ratchet wrench, it would be kind of difficult. So I'm just kind of doing a little at a time. And I have smaller hands, so I can kind of get them in here, and it's quicker to undo the bolt this way. So this is the second bolt, so now this lower unit basically will be free. The next issue I'll deal with is just the wiring. The 120 volts harness kind of looks like a big octopus of a mess right here. I'm going to start feeding this forward, and then I'll be able to see, then I'll be able to do the main power cord. So I'm going to move all my tools out of the way. Complete system's, somewhat heavy. So I'll begin pulling this forward. It kind of just had a little jump right there. This wire I disconnected earlier, everything seems to be coming out nicely. Kind of like to do it slowly just so I make sure I don't catch on any wires. There's no point in rushing, so I'll just move this out a bit at a time. And again, very careful not to pinch or break any of these copper lines. And while I'm doing this actually has an adequate cord right here. This is the main power cord, which plugs into here. So I'm going to go ahead and unplug this. I'll loop this around. And so at this point, there's the power cord's off, everything's free. So I'm going to go ahead and remove, lift this system up and out. I don't watch that. And I guess there's no point in me picking this up. I'm actually just going to place it down on the floor. So now I've removed our defective refrigeration. Okay, this section of our video basically is going to cover the installation or reinstalling a known working refrigeration system. Basically, you may not really even need to watch this section. I mean, I'm just basically going to do the opposite of what we did to install it, just the complete opposite order, but this will kind of cover it. My system here weighs over 50 pounds, so I'm just very careful about lifting it. Like, I'm going to kind of get it as close to the machine cabinet as I can. Scoot it over, and then I'll lift it up and in. All this stuff is sharp edge metal. You may want to wear gloves doing this, or just kind of be careful. It's very easy to cut yourself or nick yourself up just because of the nature of the metal. So I'm going to go ahead and very gently kind of slide it into place. I'm going to let it just do all the work. Once I had this section, the lower section in, I'll just kind of gradually put it into place. The left-hand side, I was catching the sponges. When I'm putting it in, I just want to do everything evenly. Like, for every few inches I push this in, kind of push the upper section in, and just kind of feed it back into place. Just very gently. Kind of has the feel. I can tell everything's falling into place properly. A couple important things to think about while I'm doing this. Before I bolt everything into place, I want to make sure I have access to this main power cord right here. So I'm going to run this back over here, and they had the original one was looped around as the way it came from the factory. So I'm doing this. I have that plugged back in, and then I want to make sure the wiring harness for this upper fan that I didn't, when I was pushing this back in, I didn't catch on the harness and lose track of it. So I'm going to find that wiring harness. So it's actually here. This actually did catch. So it's just very important to kind of recall all the steps. So I'm going to go ahead and this is for the upper fan. Just plug this back into place. There is no polarity on these wires since it's alternating current, so you just push them back into either clip. Click into place. Make sure they're firmly seated, just because it's just due to the moisture in here, and that's 120 volts, so definitely would not want those to come undone. So I'm going to continue pushing everything back into place. Kind of going to look through the mounting holes and get everything lined up so I can look down and see the threaded studs in the machine, just so I can get everything even. In some cases, if you're working on like the newer Dixie Narco soda machines, this would be the style of refrigeration system you'll be installing. In this case, I took one out and put kind of the same model back in. Sometimes they'll have different fins here, and you may even have to put a different mounting plate when you buy a new refrigeration system, but the method to do that is well written out, and it comes with nice instructions from Dixie and Arco in the box when you buy the new system. So what I'm going to go ahead and do is get these bolts going finger tight. Tighten these up. What I do when I'm doing these, sometimes you have to shake this lower platform around a bit because there's a little play in it. There we go, now I got it. So I had both those bolts in. So what we're going to do is tighten them, and just not to bore you with the video, I'm not going to tighten them just because everybody would understand how to do that. So those nuts are tightened. So you need to go ahead and do that. When you're actually doing it, do that yourself. For my upper system here, and I'm going to push this into place. And before I replace this plate, I'm going to go ahead and secure these screws. With this, it's kind of cheaper thin sheet metal, so it'll have expanded outwards quite a little bit. So what I'm going to do, I'm going to go ahead and grab the first screw, and I'm going to do, like I like to do the left side first, just because the one on the right's a little bit of a battle, and they have the two tabs that you bend down. I always, my way of doing it, I like to put the screws in first. After you've done a couple of these, you just may come up with your own technique of doing it. But right now I have nothing secured, so I'm going to kind of move this and look through the sheet metal and catch the hole. And while I'm doing this, I'll kind of hold these pieces of metal together, and I can feel the threads taking. I don't tighten them up all the way. I just kind of do it fair enough so that the screws are tight. I'm going to go ahead and I like to do the lower left next. And I put my hand to the back of it, I can kind of feel the metal being pulled inwards. And so I haven't tightened those all the way. My favorite one on the right hand side here, I'm going to make sure this is all the way forward, and then this metal sharp, but I can kind of, it's all lightweight, so I'm kind of holding this in place so I can see my hole. I'm going to go ahead and get this here. I guess there are screwdrivers that actually have claws that would be nice in this case, or just a good magnetic screwdriver might be make it a little bit easier to do what I'm doing. I'm just going to kind of hold this in place, and I'll get her in. Finally got her. Now this one I'm going to go ahead and tighten all the way. There's a little metal clip up here. It's just the factory design, very nice. I'm going to fold that back in place, and now I'm going to go over to my left side. Tighten these final two screws. Drop the clip down. So now need to go ahead and install my shield here. What I just did is I moved the capillary tube from the thermostat. I just kind of make sure I don't pinch that into anything. And I'm going to go ahead and this one here, kind of just going downwards. You can adjust it so you see the holes. This medium-sized screwdriver, I can catch this right one. These are basically very straightforward and easy to replace. Not too much of an alignment issues. The screws are very well slotted on this top cover. there, so everything's in good condition. Final thing, I'm going to reuse this fun black tarry insulation here just to keep this as well insulated as possible. I'm going to put this big clip, catches on the top first. I'm going to push it forward, it clicks nicely into place. So my next step, I'm going to go ahead and, probably a waste of your time showing you how to replace this metal shield, so that's just a pretty straightforward operation. Replacing this drop chute, again pretty straightforward. We'll just kind of wheel it in here. And when you're putting it in, you want to make sure that the top of the chute where the air holes are fits properly at the top of the properly and goes in, so that way it needs to be up high so when the cans hit it, it has support. Kind of everything falls into place nicely. So I have my two holes here properly aligned. So we'll go ahead and replace this screw. There's two screws that go in here. Final screw. It's into place. And in this case, these had threads in there, so you don't want to use steel cut screws. So there are a couple different screws. Just very smart when you're taking each section apart, just to put the screws in place with the component that you'll be replacing. My final step is just replacing this metal shield, and that's very straightforward, so I'm not going to include that on the video. So at this point, everything's done. You've hooked up your upper fan, you've plugged the refrigeration system back in. So after you replace the metal guard down here, your job is complete. Important consideration, if you're replacing this refrigeration system, for instance, and it was just delivered, and you're not sure if the carrier or in the box it may have been flipped upside down in any way. If you're not sure for the last 24 hours that this has been laying flat, at this point I would not power the machine, just because the oil in the capillary tube needs to come back to the compressor. So I mean, there is a possibility if, for instance, this was delivered upside down by a carrier and then you put it in, that you could damage your new system. So don't, if you're not sure that it's been flat for 24 hours, don't put this back into service. You could, as a safety, if you unplug this, the compressor will not come back on, so you could do your job and then have somebody else come plug this in, and then the machine would turn on. So at this point you're done, and all you have to do is, if this refrigeration system has been level for 24 hours, after you replace the guard, plug it in, and she'll cool down for you. And thank you for watching our video. Okay, in this section of our video on refrigeration systems, I'm going to cover the thermostat. The thermostat is a very simple and basic part. The trouble with the thermostat often is either your machine is going to freeze up, and that's because the thermostat is stuck closed, or if the refrigeration system doesn't come at all, the thermostat could be defective as well. So I'm just going to show you how to use a clamp meter just to determine if it's the thermostat. Thermostats are inexpensive. It's nice to carry a couple. Far better to start with the thermostat than to replace the whole refrigeration system, just for cost, and especially for the labor aspect of it. So today, with a clamp meter that Capital Vending sells, I'm just going to show you how to do a quick troubleshooting on the thermostat. The machine has been unplugged from the wall. You're working with 120 volts, so before really doing any refrigeration work, you always want to make sure you have the machine unplugged at the wall. So this machine, I unplugged it before we started taping. This is a Dixie Narco stack machine. Basically, the theory that I'm going to use with the thermostat, it would apply to all other manufacturers of soda machines. Down here on this model of Dixie Narco, I have my thermostat on the bottom right-hand corner. They might have slight configuration differences over the years, but this is a very typical thermostat. It's held in with two screws. I'm going to go ahead and pull this dial off right now, and just set that aside. My goal right now, I want to just take off this thermostat so I could show you how to tell whether it's good or bad with the clamp meter. What I'm going to go do is remove this now. Just 2 simple screws. So I've kind of pulled this meter forward. Generally there's going to be 2 wires going to it. You know, I don't want to pull this all the way out just because it's a little bit more work to push the probe side back a bit further. Thermostats are completely simple. Basically, it's just a switch. The common calls we get is a customer calls up and just says their machine is frozen. If you show up and you don't have any parts with you, very simple. If you just take 1 wire off the thermostat, the refrigeration system will not come on. So that's just a very good basic tip. What will happen is the fans will still spin. Maybe after 24 hours, if there was an ice block on the evaporator, it will be gone. But if you ever show up and there's an ice block there and the compressor's been running constantly, removing this 1 wire will disable the refrigeration system. So basically it just completes a circuit between these 2 wires. So what could happen is just over years of use, the contact points in the thermostat are welded together. So when it's supposed to turn off, it can't because they're welded together. So in that case, if you take 1 off, give it 24 hours, the ice block on the evaporator could, will go away because the fan's blowing through it constantly. So what I'm going to do, just for testing purposes right now, I have my thermostat out. I'm going to get my clamp meter. I'm just going to run this down. This is nice. This meter right here points to where the speaker is. So when there's continuity, that also gives me an audio indication. Basically, I'll have 1 on the meter. If I have a circuit, this should zero out. So what I'm going to go ahead and do is I'm just kind of holding this here right now. I grab my thermostat and I'm going to touch it. I'm going to touch each end of this. So right now, the one right now, I'm showing a minimal amount of resistance. You can even hear the noise. So right now I know that this essentially is a closed switch. Electricity is going from contact point to contact point. What I'm going to go ahead and do right now is turn this off. So this is another way of testing the thermostat. When I turned it off, I could kind of hear a click. This way you can kind of test and make sure that the switch is opened. So right now I'm going to touch these contact points, and my meter is currently at a 1. So if I'm touching these right now, that there is no continuity between these terminals. So if you go to your thermostat and you do this test and the dial is in the on position, that would actually be a good sign, meaning the thermostat is defective and it's not completing the circuit to turn on the refrigeration system. It's far more common that the thermostat, if you turn it off to the off position and you still have continuity, that the contact points are welded closed and your system's going to continue to run and freeze up. So here, just to kind of validate the point a little further, I'm going to go ahead and turn this on. And now when I'm touching this thing, right now, I don't know if you can see it, I guess I have continuity through the thermostat. So this thermostat, when I have this continuity, it is going to turn on your system. So once again, that's kind of the testing of our thermostat. This is just a way to troubleshoot and determine if it's okay. I mean, if you don't have a clamp meter, another just simple way is if you just have an extra thermostat, you can install it and just see if that fixes your problem. But basically, this section of the video will help you determine, with this meter, you could determine if it's good or bad, so at least you know if the thermostat is bad. But if you don't have the clamp meter, again, you could just put in a known good brand new thermostat, and you'll see if it's running. If you have a defective refrigeration system, of course, it's not going to work. In the next section of our video, I'm just going to talk about this clamp meter and just how to measure if the refrigeration system is drawing too much current. And then that way you'll know it's one way to troubleshoot if the motor and the compressor is shorted out. So thank you once again for watching our video. In this section of our video on basic refrigeration troubleshooting tips, I'm going to talk about using a clamp meter to troubleshoot a refrigeration system. The theory is, in some cases, it's very typical. If you walk up to a soda machine, if the refrigeration system's not on, the machine's not cold, sometimes I hear like a clicking and a chattering, and the compressor's trying to turn on, and basically I can use a clamp meter to verify that the refrigeration system is coming on and trying to draw current. What I very typically see is that it tries to draw too much current, indicating that there's a short in the system. It's simply, if you have a refrigeration system, you could actually plug it into the wall. If it doesn't come on, then you'll know the thermostat is bad, or the start capacitor perhaps, or the overload. In this video, I'm basically just going to do a very simple basic, show you how to, within a minute or two, determine if there's a short in the motor of the compressor in a refrigeration system. Very simple tools. First is a clamp meter, and I guess you'll take this clamp meter and I run this down right there just to where it shows 200, and I'm going to use this clamp section of the meter. Second part of your tools is just a very heavy-duty extension cord available at any good hardware store, and basically what I do, I've taken a razor blade and I've cut a slit. It doesn't matter whether it's the hot or the neutral, but I'm basically separating what this one wire on the outside from the other two wires. You could do it on either side. When you're doing this, be very careful when you're separating this. Just do it with a very sharp razor blade. Just for safety reasons, you don't want to cut into the copper of the wire. So basically with this clamp meter, I'm just isolating this one side of the AC circuit from the other side. So I've kind of clamped it there, and then what I'm going to do, I'm going to take this side of the, plug this into a wall outlet, and in my final stage, when I have this meter here, like I'll let you zoom in on this meter. This machine has not been running, so I suspect when I plug it in, the refrigeration system is going to start. I know that this machine is working, so what I would suspect, it might draw up to 9 or 10 amps, so you'll see that the meter might jump up to 9 or 10, and then it's going to keep on running. What would typically indicate problems is if you plug this in and the compressor, you see it jump up to 20. So like when I plug it in, I just like to keep an eye on it. So I'll give the machine power. So right now, I guess initially when the motor was starting, the refrigeration was starting, it was drawing a heavy amount of current. Right now this machine, it's fluctuating. It's about 6 to 7 amps of current. So this is, the refrigeration system's good. It's well within range. What would definitely be bad is, when you plug this in, really anything over 10 or 12 would be an indication that the motor is running a little too hard. It's drawing too much current. Again, this is just a secondary test. Very often when you show up to the machine, you'll kind of hear it clicking and struggling to start, will not start. In addition to that audio that you'll hear, this is a good way to kind of verify that whether your system is running or not. This machine is in great condition. It's running at now it's drawing 6.6. When this machine cools down and it's gotten to the temperature set by the thermostat, the refrigeration system will go on, and it will probably drop down to just drawing about 1 amp of current. When the refrigeration system comes back on, then it'll jump up to about 6 or 7. So this machine is tested good. When you're testing your machine using this method, again, if it jumps up to 20 at the start, that would be an indication that your refrigeration system is bad and it would need to be replaced. And that concludes our video.